Hello, welcome to my YouTube channel PyTalk. In the previous video, I have shown you that how we can use the sentence transformer for finding the similar kind of queries in the database. In this video, I will be talking about how we can use the sentence transformer for movie recommendation system. So you might have seen that when we are watching videos on YouTube itself recommend you some kind of similar kind of videos that you are currently watching in there as a suggestion. So the same we can build using the sentence transformer as well. So in this video I will be teaching you how we can how we can do the same using sentence transformer. So before starting, I would like to show you the database. So this is the actually database that we have. It contains the 4802 approximate movies, that is having the 23 columns with different information like budget, genres, home page, keyword, home page id, keywords, original language, original title. So these are the and many more the other information we have. So we know all the information is not useful for our recommendation system, but there are few keywords that we must have, that we will be using for making the recommendation system, so that this is actually one. Before starting, I would like to tell you do some initial steps so that we can use we can run the whole program on GPU, because it will reduce the time. If you are doing it first time, then this is the site from where you can download the Torch CUDA GPU version, GPU enabled like package. So it will automatically identify the GPU if you have in your system CUDA enabled GPU, and it will automatically run the whole program, and conversion will be taken place on your GPU. So I will provide this link in the description below. You can download the package from here. So here check according to your configuration of your system, like it is stable 1.10 Windows, Mac and Linux. So I am using the Windows. If you are running your your Python using the Conda, so you can use the Conda package, otherwise use the pip install package, and then Python CUDA 10.22 to 2.3. Either you can use any of these like package. So once the configuration you have set, so the link and the command will be provided this below as a. So you copy this command and paste this in your CMD box. So here, uh, paste this command on the CMD prompt, and just enter button. Press the enter button. It will because the this package I have already installed in my system, that's why it is showing that requirement is already satisfied. Otherwise, if you are doing it first time, so it will take a time, and it will be install your this package will be added to your libraries. Now we will start. So these are the three library that we must have before starting this tutorial. So import these library. uh, okay, import this library, and then movies data frame PD, the dataset that if I have shown you, its name is movie dataset .csv. So read this data set as a data frame. So I have read this as a movies data frame, and I have showed only two top values of this data set. So I will run this part of the code. We will get the two top values. Okay, so these are the different columns, 23 columns, 24 columns. Okay, here movies data frame dot info, it will actually tell you about the all details, like how many information, how many data frames are available, sorry, how many columns are available in your data set, and the total number of rows and columns. So all detail will be you can get from here. So we can see that 4803 rows are there in dataset, and 24 columns. We will not be using the 24 columns because there are some of the information that is not useful for movies recommendation system. So that's why we will be only taking those who are actually means for who's actually some who actually contribute some some information for recommendation system. So these are the features that we will be using. So I have made a list of the features that is important for recommendation system. So keyword, cast, genre, and director. If someone is watching a video of some director, so there is high chances of that the person will be liking the another movie of the same director. So like if the someone is watching a Shah Rukh Khan's movie, so there is a higher chances that the person would be liking the another movie of the Shah Rukh Khan. So that's why similarly the other information of those movies we can get from keyword, cast, genre, director. So that's why we are keeping as a features. So in this part of the code, we are just removing those columns that is having no value, or not a number, that is only not useful information as there in the column. So that's why we are removing those column with a blank space. So these all the features will be taken one by one, and the features and the column and their values will be replaced with the blank space. So we will run this part of the code. Okay, it is successfully, we have compiled this part also. So here we are, instead of showing all the data, we are only keeping those information that is relevant, like cast, director, keyword, and genres, and the title. So I am showing you only these information, because the rest of the information is not actually means for us. So run this part of the code, we will get the details like avatar and their cast, the director of this movie, then keywords and the genres. So this we can see from here. And the another section of the code is actually because these individually cast, director, keywords, and the genres is actually contributing some information for deciding the user's choice of that movie. So that's why instead of taking as an individual, we will take benefit of these individual by combining all these features as a combined features, and call it as a movies data frame, and next a separate column of that data frame, movies data frame, as a combined feature. So here we have combined movies data frame, keyword, and then cast, then then movies data frame. Here we are keeping one space, so that the before combining the another that column, it will provide any space. So we are combining all these information and keeping as a combined feature. So once I will run this part of the code, we will get the combined feature. So here this is the combined features. I can show you the one particular one. So if I'm taking as a 0, suppose 0th I'm taking, so this is actually this all combined information. Here in this information, that I have shown you, keyword, cast, genres, and the directors, all this information is actually combined together here. So in next section of the code, I will show you that how is this is actually a data frame, pandas data frame. So first take all the values of that column, combine features column, all the values of this column, convert these into the list, so that we can proceed further. So that this movies data frame combine feature, and convert this to the list, and this store as a movies db, so we call it as a movies database. So run this part of the code. You can see that all the values of this combined feature, like this information that I have shown you here, first 0th indexed movie and their information, and their first index movie and their so on. So all this information is actually converted into the list format. In earlier this was in data frame, so now it is converted into the list format. So all this information we can get here. These are actually list and separated by the commas. Once we have done this so far successfully, so next we will initialize the sentence transformer, which we will be using for the embedding purpose. So here is the sentence transformer model. This is actually model. We are sentence transformer, and model name is this one. So this is actually, there are multiple model available on the Hugging Face library. Sentence transformer, I will show you that. Sentence transformer, Hugging Face library. So this is actually the website where you can get all the models and their names here. But Actually, I have tried multiple, but the one which was giving more accurate result was the All Mini LM, LX, and version 1. So this was giving the more actual results and more accurate results. So that's why I have chosen this one for this video. So we can initialize this, run this part of the code. This section of the code, it will take a time to initialize the model in your local system. And the next part of the code is actually, we once we initialize the model successfully, that model is actually, this model is initialized as a named as a model. So now we will use this model for the encoding of the database that we have in our movies list. So this was the actually movies database, as a listed format. In the list format we have all the database. So now we will be encoding this information. So instead of like, earlier I've explained that why we are converting from sentences to the embedding, like vectorized format, because the sentence and the words cannot be directly given to the machine learning algorithm. So that's why we need to convert those information, those sentences. Each sentences will be converted to the vectorized format. So vectorized format, it means that each one sentence will be converted to the number, some kind of weighted number that is decided by the sentence transformer in the model that we are using. So it will convert this model into the vectorized format. So here the information that we require is actually model dot encode and then movies dv. Movies dv is actually the total database, and the convert to the tensor false. Here I will be keeping the true. Okay, true, and the progress bar, and then device CUDA. Actually, if you are not writing this as a specifying this as a CUDA, these all are the optional. So these information like convert to tensor, show progress bar, and the device. So this all information is optional. If you want to choose, you can specify that. Without this also the code will be running. So, without any errors. So and the device, if the like I have already specified here, because I just want to show you that we can how we can use the GPU and how we can use the CPU. Suppose this I am written is CUDA, but if you are changing it the CPU, if you are writing this place, if you are mentioning that CPU, so that model will be using your CPU. And if you are not showing mentioning anything, so automatically it will identify the GPU. If it is the system is GPU enabled, so it will automatically use that one. So we will be running this part of the code, and it will take some time, but because I am running the whole command on the GPU, so it will take a very less time. I think less than 15-13 seconds once it will start. So you can see how quickly it is, that progress bar is successfully completed. 100% of the coding has been completed, means like 4800 data has been like vectorized and embedded in a very less time. How much time it took? Only 12 seconds it took. But if you are performing the same on the CPU, you will be realizing that it will be taking at least 15-20 minutes. 15 minutes it will take for the conversion. So in the next part is the, actually this is the movies DV, and embedded is actually the converted part. So I will show you the shape of this data, because we were having the records of 4803 movies. So that has been converted as a row, and each row is containing 384 elements, because this model is actually converting the one particular sentence and one particular vector to the 384 elements it is encoding. So I will show you that vector as well. So okay, there is some mistake I have done. Okay, this is actually this is the total embedded vectors. So the size of this vector is 4803 and 384. So it is having the 4803 rows and 384 columns. In the next section I will show you that we will calculate the similar, we will calculate the cosine score for the database that we created embedded here. So this data we will create the cosine, calculate the cosine score. So the command that we will be using, util pytorch cos sim, this is actually method for calculating the cosine similarity using the pytorch, then specifying the database, and then again specify. So here you can see that I am calculating the movies database embedding with movies database embedding itself. Why I am doing this I will be explaining. So first run this part of the code. You are getting like you can see, because I'm doing this because I want to calculate the each particular movie similarities with the other data sets. So that's why I'm keeping both same, so that we can get a like a covariance kind of matrix. It will be showing you that each one particular movies combined feature is actually calculated the cosine similarity of one particular combined features with the other movies in the database. So you can see the first one is actually calculated with the first itself, so that's why we are getting the one. Now the second is actually calculated with the second itself, that's why, because the second is actually second calculated the cosine score for the second movie itself, so that's why we are getting. So we will be getting the 1 1 1 in the diagonal space. Rest of the column in the rows elements are actually the similarity with their corresponding movies data. So here cosine score, and we will get the shape. Now we can check the shape. So shape is actually 4803 4803. It's a total number of rows, like total number of movies, and then it is again 4803 and 4803. It's a kind of the like covariance kind of matrix. So we have calculated. What is the benefit of doing this is actually we don't need to calculate the cosine scale every time. The only thing that we need to is we will put every like movies user like, so we will give the information about the movie that user is actually watching or user liking that movie. So we will give that information, and just with this information only, without calculating the cosine score again and again, we will be able to recommend the movies on the basis of this user input. So this we have done. So in this part of the code, I will run this part of the code. So user like memory is the Avenger, and here we are actually with this we will try to find out the index, like at which place and at which index that this movie is actually existing in the database. So movies data frame title, we are searching for the title, and then we are condition putting a condition is equal to movie likes user. So this is to actually provide you a true false condition, and only those information will be returned which is having the true values. Rest of the information, rest of the columns and the rows will be false, and that will not be returned into your database. So that's why movie data we have passed the information, this information as a movie data frame. So this part of the code, and from this compiled movie data frame, we are taking only indexes, that is zeroth elements. Okay, this okay, you can see the sixth in this movie is actually existing at the 16th place. So we can check from this database. 16th place is this one, so you can go and check the title. Title, okay. So you can see the Avenger is actually at the 16th position. You can check here. So it's we have identified the that movie's location, this movie location. Now we will put a condition of how many movie that we want to recommend to the user. So like if I am recommending the top 10 movies based on this which look like which is having the similarity of these movies. So we are getting this I am defining this condition here, that top 10 only we are trying to recommend. So the torch, and then we are filtering those information like at top torch, then top k, then cost secures, and then we are putting that movie index for 16, because we have already calculated the cosine scores, and we are just putting the that index number here. So cosine score for the 16th movie, and then top k. So it will calculate the actually when we are putting this cosine score now, then I will show you here what is actually it means. And when we run this part of the code, we will get only one particular tensor array, instead of, because the cosine scores was having the size of 4803 and cross 4803 matrix. So from that all information we are getting only that information that is actually having the 16th 16th place. So we are getting only one tensor that is having and it contains all the information the similarity with the all other movies in the database. So that's why we are taking only this. Okay, so when once we will run this part of the code, we will get the indexes as well as the it will be like top 10 elements. It will pick up the top 10 elements. It will first sort those in the descending order. So that is a separate process that Torch is itself handling those criterias. So you don't need to do all those things, but the return vector will be having the matching score, top 10 matches score, and their indices as well. Like one is actually because the movie itself is a the Avenger, and it was located at the 16th indices position, so that's why we are getting a 16th. And obviously the Avenger is actually will be having a more similarity with the Avenger itself, so that's why we are getting one first vector as a 1, cosine similarity as a 1, and the index is a 16. So similarly the other cosine similarity we can see here, it is reducing, and their their similarity with the other movie, like the Avenger is similar with the movie which is at location 7, and its similarity score is 0.8171. So the another is like the Avenger is movie is similar to the movie that is available at 85th location, and its cosine similarity score is 0.7636. So that we have shortlisted from here, and now we will put a condition print, and this user like what movie that user likes, and we are recommending the top 10 movies. So I will run this part of the code. We are getting a top scores like this top results containing two information. One is that cosine score, and another one is the indices. So that's why we are getting those separately, and we are starting from first position, because the first zeroth index, because this is a list and this will be starting from the zero. So the zero is itself the Avenger which a user is already watching. So that's why we are not showing this as a results. So that's why I am starting from the one position. So one is started, and all the feature, all the rest of the results, and then here for the same. And top result 0 shows like we are top 0 means this is actually zeroth element, and this is actually your, I will show you. Wait a minute, like tensor cosine score. This will show you the cosine score of this is the calculated cosine score, you can see. And when we will run the top result one, we will get the indices corresponding to their cosine score and their indexes. So we are getting these two information, so that these two information will be run to in the for loop, so that we can get the score. And the IDX is actually a location ID where the that movie is actually located. So this information we are plotting in for loop. Then plotting the movie's eye location is actually choosing that particular movie and its title, and then we are plotting the score, how much similar it is to that movie. So once we will learn this part of the code, we will get the details of top 10 movie recommendation for movie The Avenger. So the user was watching, if the user is watching The Avenger movie, so these are the movie that user might be might watch in the next recommended from the list of the recommended movies list. So you can see, so the first recommended is Avenger, because the Avenger he was watching. So there is a high chances of that he would be watching the next movie, The Avenger Age Ultron, and the scores is 0.87. So on the basis of this score, actually these movies are being shortlisted. So